Hello everyone, welcome back. My name is Bappy Hamed and welcome to my YouTube channel. So guys, in this video I'm going to show you how we can train state-of-the-art object detection model with our custom data. So guys, many of you have already requested me for this particular video, like how we can train like object detection model with our custom data. And many of you have already requested me for the Yolo v5 training. Okay, so in this video I'm going to train one state-of-the-art object detection model, which is nothing but Yolo v5. And guys, in this video I'm going to use some of the open source easy to use tools and technology. So whenever you are training this kinds of object detection model, so definitely your task would be very easy. And guys, if you check out my YouTube channel, so I have already created lots of playlists on top of this computer vision and NLP and generative AI. Even I have also created like lots of end-to-end projects and all. Okay, you can refer these are the video as well. Even I already showed you like how we can train Yolo v8 model, Yolo v7 model, Yolo v6 model. Okay, so today in this video I'll also show you like how we can train Yolo v5 model, because this is the most requested video. Okay, I'm getting. So what I will do, guys, first of all, I'll show you the Yolo v5 repository. So I think that would be clear if you don't know what is Yolo v5. If you don't know, Yolo v5 is an actually object detection state-of-the-art model. Okay, and this is the performance of the Yolo v5. And guys, this is the official GitHub repository of this Yolo v5, and this is the research from this Ultralytics. Okay, this is the organization. They have proposed this Yolo v5 model, and this is like very active research. As you can see, only 3 days ago there was a last commit. Okay, so if you are having any kinds of issue with this model and all, so definitely you can create a issue. Okay, it would be closed very quickly. So here is the installation guideline, like how we can install this like repository and how we can use this Yolo v5. Everything they have given, okay, as a documentation and everything. So what I have done actually, I have already created one easy to use notebook for you. So I'll just show you the steps, like how we can perform this object detection task. How we can train our like own model, okay, own like you can say custom model with our custom data. So that's why actually I already prepared this notebook for you. Okay, I will execute this notebook and I will explain okay, what you need to do. And if you have this notebook, guys, you can train any kinds of image. Okay, so only you just need to change the data here. And guys, don't worry, I will also show you some of the like free to use and open source like tools and technologies, so you can use them like to do these kinds of object detection task. Okay, so definitely your like productivity will increase there. Okay, so guys, what I will do, first of all, let me show you the data set actually I'm going to use. So guys, this is the data I already collected. I haven't collected like lots of image here because I just wanted to show you how we can train our model, okay, on top of the custom data, because again I'm going to show you the annotation part of the data. Okay, so that's why I haven't taken lots of data here. But if you're training your own model, make sure you have like lots of images. Okay, so what you can do, you can collect, these are the images I have already collected. And if you don't have these kinds of images and if you don't want to collect, so I'll also show you one alternative you can use. Okay, so there is a website called Roboflow. Okay, you can visit Roboflow. So guys, Roboflow is an amazing platform actually they have developed, and here actually we'll get all kinds of solution in the field of computer vision. So let's say you need actually dataset, okay, for your model. You want to train a model, actually you need a dataset. Okay, you don't have the dataset. So what you can do, actually Roboflow has one you can say product called Universe. Okay, so from the universe itself you can collect the data. So how to get the universe? So definitely you should have one account. So I already have the account. So let me just log in with my account here. So guys, as you can see, this is my account. I have already logged in. So if you don't have account, just try to create an account with your like you can say Gmail. So definitely you will get this kinds of interface. And if you don't have any projects, so don't worry, you can create a projects from here. I will show you how to create the projects and how to upload your data, how to do the annotation, everything I will show you from here only. Okay, now here if you see, guys, here is one section called Universe. Okay, now if you go if I go to the Universe, see, Universe has actually different data set, okay, with respect to different tasks. Let's say you want to perform something called object detection. Okay, you can select the object detection from here. So let me select the object detection. See guys, all possible actually object detection data are available. Let's say you want this helmet data. Okay, see, I already took some images from here. I downloaded the images from here because see, I just wanted to show you the annotation part. That's why I already downloaded the data from here. Okay, so let's say you want this data, this helmet data. You can click on the data. And guys, if you see here, lots of images are there. Now if you want to see that images, okay, you can open it up, and this image is already annotated. As you can see, if I click on the image, so this is already annotated. See, this is already annotated, like and it is already splitted like training set, testing set, validation set. Only what you need to do, you need to download this particular data. Okay, what you can do, you can directly download the data. So here, let's say if I click on this image, so you can see this is already annotated as helmet, as you can see. Now let me go back. So guys, as you can see, all the image is already annotated here. I don't need the annotated image because I'm going to show you the annotation, like how we can perform. Okay, but if you want to use as it is, like with the annotation form and all, you can use it. See, not only this data, you can find lots of data. Let me show you. So let's say if I click on object detection now, let's say I want this, let's say this boat image. Okay, I will click on this boat image. Now here you can download the data. Okay, as you can see, there is a button. You can download directly. You can download as a zip file, as well as you can also download with the code snippet. See, if you want to download as a zip file, you need to select download as a zip file, and here you can select the format. Okay, like the format you want to download the data. So let's say you are training Yolo v5 model, so you need to select this particular option, Yolo v5 PyTorch. Let's say you are training with Yolo v7, you need to select this particular you can say option. So that's actually you can select different format of the data. So let's say I want to use Yolo v5 PyTorch, I'll select it. Now if you want to download with the code snippet, it will show you the code snippet. If you want to download as a zip file, you can also download as a zip file. So let me download as a zip file and show you. See guys, if I click on export, see it is downloading. See it will do the zip operation, then it will download the data. I will also show you how we can download using code snippet. It is like very easy to use. Whenever we'll be uploading our custom data there, and we'll be doing the annotation, after that we can do it. See, it has started downloading the data. Okay, as you can see. So guys, as you can see, download is done. Now if I show you the data, like how it is look like, okay, what is the format of this Yolo v5, because we are going to train Yolo v5, definitely we need to check it, and no need to worry about the format. Actually it will automatically create if you're using Roboflow. But if you are using some open source tool, okay, let's say some open source tool are also available, third-party tool. Let's say there is a tool called label img. Okay, so this is another tool. So with the help of this tool, actually you can also do bounding box annotation. But here you need to take care about the format. You need to also take care about the tentative split, everything you need to take care manually. Okay, so it is like more time taking task. So what I feel like using Roboflow, it's very easy, because there you don't need to organize the data. So everything can be done by the platform itself. Okay, now let me show you guys the data actually how it is look like. So guys, as you can see, I have here some of the folders and files. So we have training set, test set, and inside that I have a label and image. Label is nothing but your txt annotation. Okay, the Yolo annotation, and image contains the image actually. The image actually you are gonna use. Oh, okay, see all the image. So that's actually your folder will look like after doing the annotation and all. And it will have another file called data.yaml. Okay, inside data.yaml you will have all the classes name as well as the data path. Actually let me show you. So see guys, here I have, these are the classes in this data, and this is the path of the images. Okay, and number of classes you have to define. So these are the thing actually it will automatically take care, no need to worry about. So I'll just quickly cancel this, and what I will do, I'll go back to my data. So this is the data I'm going to use, called helmet data. Okay, I have collected, these are the image, because I can't actually annotate all the images in this video, so that's why I've taken this image. But if you want huge image, so what you can do, you can download this particular image. Okay, here you'll get like 1149 images, so it is like enough, I think, to train one model. Now what I will do guys, I will go back to my Roboflow. So let me just close this at the tab, and let me go to the Roboflow. And here you will see the project section. Now click on the projects. Make sure you have already one account and you have signed in. Now here I'll create one project. So I'll just click on new projects, and here I'll just give the name of my project. So let's say here we are doing helmet detection. Okay, so I'll just write helmet detection. Now here you need to select the task you want to perform. I want to perform object detection task. Okay, you can also perform classification, instance segmentation, as well as key point detection and semantic segmentation. See, all the tasks are possible. Now I'll select object detection, and here you need to give the annotation group. Okay, so here I want to only detect helmet, so that's why I'll write helmet. If you have some other also, what you can do, you can if you see here, this is the format they have given, you can mention comma, okay, to represent all the level you have. Let's say you have something else. Okay, so what you can give, you can give comma or this hyphen, and you can write another. Let's say you want also hat. Okay, that's how you can mention. But I only need helmet, so that's why I'll give helmet here. Then I will create this project. So see guys, my project has been created. Now you just need to upload your data. So now what you can do, you can select all the data and you can just drag and drop here. Otherwise you can also select your folder you can upload. This is also possible. See, I have already uploaded all of my data. Now once everything is good, now what you need to do, you need to just click on save and continue. Now see guys, my data is uploaded. Now it will see, it has some more functionality. It will tell you, do you want to assign this image for your team member also? You can also add your teammate. Let's say you have huge amount of data and you are working, let's say 7 people in a team. You can divide this particular data to 7 people, so they will get some of the like image to annotate. Okay, you can also add them. So this is also possible, and this is a good I think I mean functionality they have included here. So in this case, I don't have any teammate. I'm the only one. I'll be doing the annotation. So what I will do, I'll just assign me. You can see this is my account. I have already assigned, and I have 19 images here. I can annotate by myself. Now I'll just assign the image to me. Now guys, you can see here, these are the unannotated image and I haven't annotated yet. So that's why annotation is 0. Now what I will do, I'll start annotating. So I'll just click on this button, start annotating. Now guys, we can start annotate the image. So I want to detect this particular object, which is nothing but helmet. So I'll select this one, and this is the helmet object. Okay, I'll just I can also press enter, it will save. Otherwise you can also click on this button called save. Okay, once it is done, you need to click on the next image. Okay, now let me click on the next image. Then again I will select my helmet. Make sure you are annotating in a good way. I'm just doing it quickly because I want to finish it. You just try to make sure you are tracking each and everything, okay, of the object you are annotating. So try to get a try to like take in a good way. Now this is also helmet, save. Then this is all my helmet. Okay, so guys, what I will do, I'll just quickly annotate for all the images I have here. As you can see, I have 19 images. I will pause the video, I'll complete and I will show you, okay, once it is done. So guys, as you can see, all the 19 image has been done. Okay, so here I have done the annotation manually. And there is another video I created, I think you remember, in my YouTube channel. So there is a tool actually from Roboflow itself called this auto distill. With the help of this auto distill library, you can perform auto annotation. Okay, image auto annotation. So make sure you are watching this particular video if you want to perform auto annotation. Okay, so both way you can do, but it depends upon you, because see, whenever you are doing auto annotation also, you need to give some manual observation whether everything is annotating perfectly or not. Okay, so that is why I'm showing both process actually. Now see guys, it is done. Now what I can do actually, I can go back. So all the image annotation is done. I can go back. Now see guys, I have annotated 19 images. Okay, now see, I need to add all the images to my data set. Now see, it is giving the train test split option. Now here you can like give the size, how much image you actually need for the training, validation and testing. So this is the default size. I'll keep this size, and this is the number of image actually you are getting for the training, validation and testing. So here I have only 19 images, that's why it's showing like that. But whenever you are training your own model, make sure you are having lots of data. Okay, just to show you the demo, I'm taking this particular image. Okay, now what I will do, I'll just add the image, so it will automatically do the split operation. Now see guys, it is done. Now if you want to see all the images, now you can click here. Now it will show you all the images. Now if you just click on the image, see, this is the annotation you have done. So everything is fine, and we have also generated the annotation. Now what I can do, I can go to the health check. Okay, you can also check the health of your data, whether everything is good or not. You can see this graph actually. So how many images you have, how many of them you have annotated, and what is the image ratio, everything you can see from here. Now I'll just directly generate my data. I'll click on generate. So here you can perform some of the processing technique. Let's say if you want to perform resize operation, auto orientation, I think you have also heard of something called augmentation technique. Okay, in computer vision, you can also perform augmentation. See, augmentation is also possible, different augmentation. So you can add augmentation, but I'm not going to add augmentation. See, you have different augmentation. You have flip augmentation, 90-degree augmentation, then you have blower, grayscale, saturation. Okay, all kinds of augmentation are available. So here I'm not going to perform any kinds of augmentation. If you have very less data, you can perform it, but I'm not going to show it. Now here I will just directly create my data, and let me just create the data. See guys, this is the version of the data it has created with the timestamp. Now you can also train with Roboflow. You don't need to use any kinds of different notebook. You can directly train with Roboflow platform. But for this, actually, you should have like you can say premium account of them. So now here what I will do, I'll just export that data. Now here if you see it is telling format, I will select this particular format because I'm going to use Yolo v5. Now here I don't want to download as a zip file, I will just take the code snippet. So let me just generate the code snippet. So this is the code snippet, guys. Now I'll just copy this code snippet and I'll go to my notebook, and if you just go below to this notebook, you will get this section actually. So make sure you are changing this particular code. And guys, don't share this API key with anyone. Okay, I'm showing because I'm just I'll delete after the recording. Okay, that's why I'm showing. Now guys, as you can see, it will automatically go inside your projects and it will download that particular data. Okay, now guys, I need to just connect my notebook. And guys, now what I need to do, I need to clone this particular Yolo v5 repository. As you can see, this is the repository I need to clone. Then after that, I will be doing some setup, requirement setup. Then I can use this particular repository to train my Yolo v5. Now let me just clone this particular repository. So left hand side, you will see it will clone. See guys, it has cloned. Now I will be installing the requirements inside Yolo v5. I have this requirement.txt file, okay, and all the requirements they have already given. You have to install. See, I need to install them. So let me just install. So it will take some time. Let's wait. So guys, as you can see, installation is done. Now what I need to do, I need to download the dataset from the Roboflow. So that's why I need to install this Roboflow package. So Roboflow has this package, actually Python package you can install with the help of pip. And after installing, you can use this code snippet you have copied from here, I think you remember, and you can download the data. See, it's done. Now if I execute this particular code, you will see it will download the data. See guys, it has downloaded. Now if you want to check where it has downloaded, now here you can check the current working directory you are in. So you can write pwd. So maybe I'm inside Yolo v5 folder. Yeah, inside Yolo v5 folder. Now here, if you want to check the data location where it has saved the data, so you can call this particular data object, and here you just write dot location. Okay. So if you just execute, it will give you the data location. See, inside content Yolo v5 helmet detection project 1. Now see this is the dataset it has downloaded. As you can see, inside that I have my training image, and here is the label. Okay, that means txt annotation. As you can see, bounding box annotation, and as well as my images also. Okay, so everything is fine, guys. That means we are able to download that data and validation, and all the things are available. Even my dataset data.yaml is also available. I have one particular object classes called helmet, and this is the classes, and this thing is not required. This is the some metadata from Roboflow, and this is the path of the image. Okay, that means everything is fine. Now what I will do, guys, if you want to check the content inside data.yaml, so you can execute this particular command. It will take the data location and it will print this particular data.yaml with the help of this cat command. So cat is a Linux command. With the help of cat, actually you can see any kinds of content in a file. Now guys, what I need to do, first of all, I need to extract the number of classes. Actually, as you can see, inside this data.yaml, I have my number of classes. Okay, like how many number of classes we are having. So we have only one classes. So this thing, first of all, I need to extract. So for this, actually I have written this particular code. So it will open up the YAML file, data.yaml file, and it will extract this particular number of classes, that means NC, and it will store inside this variable. Let me show you. See guys, now if I print this number of classes, that means it would be 1. It has already extracted from this particular file, right? As you can see, it is 1. Now what I need to do, I need to choose my model, like which model you want to train here. So here you have different model configuration. If I click on the model, as you can see, inside Yolo v5 I have model. Now here you have different model. Okay, if I also show you from the repository itself, you have different model. Okay, from the model view. So here I'm going to use this particular model called Yolo v5s model. This is the smallest version of the model. This is the N model. That means this is the nano model. This is the medium model. This is the large model. This is the X large model. That's how you have bigger model. So I can use this particular model because I can quickly train, and this is the performance of the model, size and the MAP score. Then speed of the model, okay, and parameter, it is having 7.2 million parameter, and this is the flop. Okay, so all the configuration you can check from here. So I'm going to use this particular model. So for this, I have this configuration Yolo v5s. This is the configuration. Now if I open this configuration, you will see all the model configuration is already written, and by default the number of classes is 18 here because it has trained with Coco dataset. Okay, so if you don't know, Coco is a object detection object detection actually benchmark dataset. So whenever anyone train any kinds of object detection model, they use this Coco dataset. Okay, so Coco has different actually classes. Okay, so the dataset they are using, it is having 18 number of classes. So I just need to change this particular parameter, because here I am doing the fine tuning operation, right? I will be taking the pre-trained model. On top of that, I will train my custom data. The data actually I'm using called helmet data. So that's why I need to change this parameter to 1. So for this, actually what I need to do, this is the code I have written. First of all, if I do the cat operation on this Yolo v5s.yaml, you can see all the content. I just need to change this parameter. So for this, I have written this particular code. So this code actually what it will do, it will apply this particular variable, okay, on the notebook cell only. Okay, that's why this is required. This is one magic cell I have written. And now see guys, all the content I copied from here only. If you see here, all the content I copied from here. I just copied all the content and here I pasted. Then here the number of classes I only changed with my variable. The variable I'm extracting, that means 1. Now once it is done, I'm just writing. Okay, I'm just writing inside the same folder. As you can see, inside model folder, I'm just naming this file as custom_yolo_v5s.yaml, because I don't want to change the official file. Okay, I will be creating a copy of the file. That's why I have done this particular code. Now if I execute this particular code, you will see in the model folder, it will create another particular file called custom_yolo_v5s.yaml. See, now nc is equal to 1. That means we have successfully changed this parameter. Now we can start the training. Now you can see this is the training code, guys. It's like very easy. Like if you are using Yolo v5, so it's like very easy to train. And we have also seen like how to use Roboflow to prepare the data. Maybe you are getting interest. Now see guys, this is the final command. So inside that you will see something called train file. Here is the train file, train.py. So you need to execute train.py. Here you need to define the image size. This is the default size you can keep. Batch size, number of epoch you want to train. So let's say I want to train only 100 epoch. Okay, just to show you the example. So guys, just to show you the demo, I'll just train 100 epochs because it will take time. Okay, or else I can take 50 epochs. It will take less time to train. You can train with higher epoch, okay, and make sure you are having lots of data, okay, otherwise you won't be getting any kinds of prediction. Here I have only taken 19 images, that's why I might not get prediction, but the process will remain same, okay, whenever you will be using huge data. Now here you need to pass the data YAML file path. It is available in the data location I am giving, and here you need to specify the model configuration. See, this is the configuration we prepared. This configuration path we are giving custom underscore Yolo v5 s YAML. And weight, I want to use this particular weight, Yolo v5s model, okay? And you need to add PT. PT means the extension of the model file. And here you need to also define the output directory, which is nothing but Yolo v5 results. Now, if I execute this particular code, it will start the training. First of all, it will download that particular model. If it is not available, then inside Yolo v5, it will create one folder called runs. Let me show you. See, runs has been created. Inside runs, it has created train folder. Inside that, this is the output folder, and inside that it will save all the metrics and weight. See guys, it has started the training, and currently one epoch is going on, and this is the box losses and classes losses and MAP score you are getting. So MAP score should be high and losses should be low always, okay, whenever you are training the model. So this thing I already explained in this video, the object detection video I created before. Also, so I have already explained these are the thing inside those video also, okay, you can check it out. Now see guys, training is going on, so what I will do, I'll just wait, I'll pause the video. Once this training is over, I will come back. So guys, as you can see, my training is done and it has already saved all the results in the results folder, and it took 1 minute 8 seconds to run. Now if you want to visualize the results actually, so as you can see inside results folder, it has saved all the matrices, okay. And this is image, so I don't need to open it up from here. What I can do, I can directly visualize it here. So inside Yolo v5 results, you have something called results.png. So it is having all the matrices. Okay, now let me visualize it. If I execute, see guys, you will see the results matrix. See, this is the losses, this is the object loss, and again loss and MAP score. So guys, see here I'm using very less amount of image, that's why this image is not looking good. But if you are taking like huge amount of data, so there actually will see your model is learning, but somehow I'm getting something. Now here, if you want to check your batch images, you can also plot them here. See, these are the batch images actually, some of the batch images with the, you can say actual annotation, helmet. You can also see the augmented image, okay, during runtime. It is also possible. See, what Yolo v5 do actually, this framework they have developed. it also applies this augmentation in the runtime. Okay, and these are the augmentation. As you can see, it has attached some of the picture, it has done some brightness changes. Okay, as you can see, these are different augmentation they have applied. Now if you see here in the weight folder, I'm having the model, okay, base.pt and last.pt. This is the model I need to use. This is my trained model. Now to check it, so you can execute this particular command, and I'm having this two model. Now I'll be using this base.pt to do the inference, okay, on top of my test data. So this is the file you need to execute that time, called detect.py. As you can see, detect.py, and here you need to pass the weight. So base.pt you need to pass. So here is my base.pt. Inside run results weight base.pt. Just copy this particular path and paste it here. Image size, confidence score, and your testing image path. Okay, so in this case, this is the testing image path. So let me show you. Inside helmet, I have test and I have image. Now I can copy this particular path. I'm having only two images in this particular folder. Now here I will just define. Okay, this is the path. Now if I execute, it will take those testing images and it will do the prediction. Maybe I'm not going to get any prediction because I'm using very less image and I trained only 50 bucks, so that's why maybe I'm not going to get anything. Now if you want to see, it has also created one folder inside runs called detect. Inside detect, it has created experiment, and this is my prediction. So let me check. See, no prediction is there because I already told you I'm using very less image, and image resolution is not good also, so that is why. Now if you want to show on top of this notebook, you can execute this particular command. It will pick up all the images from the folder and it will show you. See guys, okay. So in case guys, what you can do now, you can use the Roboflow Universe. So I have already shown you different data set is there. You can select your task, let's say object detection. Now you can use this particular image called this helmet image. Okay, this helmet image, you can download this particular image. Okay, it is having I think I already showed you 1000 more than 1000 images. Okay, you can see here, and you can train one model on top of it, and it is already annotated. You can directly download this particular image, okay, and you can use it as it is. Okay, so that's how actually we can do this custom training of our Yolo v5 model, okay, with our custom data. I hope you got it, and you can use these are the open source tool and technology, okay, just to make your task easy. Okay, so definitely you can try with your own data guys. I hope you like this particular video, and if you have liked this particular video guys, make sure you are doing subscribe to my channel and share this video with your friends and family. With that guys, thank you so much for watching this video, and I'll see you next time.